Hello, my name is Emrah Karagöz, and I will do the demonstration for Lab 3. So in this Lab 3, we are given an input A, and which is registered, which is stored in R4 in the beginning. It will be 5, and then we will calculate X and store it in R5, and we will also compute F and store it in R7. X, the computation of X and F are given here. For X, we need a loop, the summation loop here. For F, it's basic for X plus 27 over 2. Okay, so in the skeleton part, this is the skeleton of the function. Okay, it's given. We are just supposed to fill the summation part. The F calc part, and X calc is okay. Yeah, that too actually. And factorial, that part. And we are already given the multiplication. Multiplication performs as it takes R5 as a multiplier and R6 as the multiplicand, and store the multiplication of R5 and R6 in the R6. Okay, so okay, I will close this. So let's go back to our code. This is my code. Okay, let me do it 5. Okay, this is 5. This is the initial value of A stored in R4. It's 5. We clear the registers R5 to R8. Okay, in the beginning, A is copied to R5, and we call the absolute value function to compute the absolute value of A, and it's stored in R5 again. Okay. In the summation part, R5 is copied to R6 as the starting value. This is by the way, we will we will use the R5 as the counter in the summation. Okay, and in each step we will decrement this R5. This R5 performs as the I in the calculation of X actually as the counter. Okay, but we start with R6, the value A, then we decrement R5. I mean, we perform the loop for A minus 1, A minus 2, A minus 3 till 0. For the last thing, because when I becomes 0, which is R5 actually, R5 becomes 0, we should go out of the loop actually, okay? Because I'm using J and Z. So when R5 becomes 0, I will go out to summation. But for 0, there is a 2 times 0 factorial, which is actually 0 factorial is 1, 2 times 1 is 2. So I need to add 2 to accumulator, which is stored in R8, okay, for 2 times 0 factorial. Then this accumulator is stored in the R5 X as the result of X calc as the X, okay. So let's go back to the beginning of the summation. We need to call factorial, okay. We start with A, then the absolute value of A actually. Then we decrement the absolute value of A by 1 in each step. And in each step we need to compute 2 times I factorial, okay. This factorial part just computes I factorial, so I will go through to the factorial part. So R5 is the counter, which is I. I need to first copy the value of R5 to some temporary, I mean, I'm using R9 as a temporary register. So I copy the value of R5 to R9, okay? Because I'm gonna use another counter, but let's say J, but it's again, it will be R5. Why? I'm sorry. I need to use R5 as the counter again, okay? But R5 is also used as the counter in the summation, okay? So I need to copy the original value of R5 to R9. So in this factorial loop, in each step, as it is given in the hint, we start with the video in R6 and we multiply the R6 with n minus 1, n minus 2 up to 1. Okay, and for this, these videos are stored in R5 actually. Okay, n minus 1, n minus 2 stored in R5. We decrement R5, so we get n minus 1, n minus 2, and 1, and to 1. Okay, so that's why I need to store the original video of R5. Okay, in each step, this is the factorial loop. In each step, we decrement R5. In the beginning, it was n, but when you decrement it, it becomes n minus 1 for this. Okay, so it's now n minus 1. If it becomes 0, we end the function. Okay, we go to factorial end. And we call the multiplication. If it's not 0, we go and we continue and we call the multiplication function. In multiplication function, R5 and R6 are multiplied and the product is stored again in R6. Okay, so in the beginning it's n minus 1, R6 was n, so we multiplied this together, so it becomes n minus 1 times n. Then we go back to factorial loop again, decrement the R5, it becomes n minus 2. So when we multiply n minus 2 with R6, we get n minus 2, n minus 1, and n. And when we go like this, we finally get the n factorial, okay? Because when R5 gets to 0, we end the loop, okay? We directly go to the end. And since we are going to use the original video of R5 in the summation counter here, okay? So I restored the original video of R5 by taking from R9, okay? So this is the brief summary of factorial part. And for the summation, let's go with summation. So I factorial is computed in each step. Now let's go back to the counter R5. R5 is actually I, the counter I. So this is I factorial. R6 times R6 plus R6 becomes 2 times I factorial. And I add this R6 to the accumulator, okay? In the beginning, R8 was 0. So in each step, 0 plus 2 times A factorial plus after another loop, another step, 2 times A minus 1 factorial, 2 times A minus 2 factorial, until it becomes 0. R5 becomes 0. When R5 becomes 0, it ends, the loop ends, and we need to add 2 more to R8 for the 0 factorial thing. I mean, for the I equals to 0. Okay. So for the fcalc, R5 is copied to R7, which is x actually. So we need to compute 4 times x plus 27 over 2. For computing 4x, we just need to shift left twice, because in the first shift it becomes 2 times x, in the second shift it becomes 4 times x, and then we add 27, and we do the shift, right shift to compute over 2. I mean, to divide the 2. Okay. So let's debug it. I will go step by step. R4 is 5, as you see here, it's 4, R5. We clear the R5, R6, and R7. By the way, I'm sorry, I need to make it default. Okay. Okay, R8 is also 0. They're all cleared. R4 is copied to R5. It's 5 in R5. The absolute value of 5 is 5. I don't need to go. Okay, let's go back to factorial. Okay, now we are in factorial. Let's step into factorial part. R5 is 5. So I copied the 5 to R9. Okay, the original value of R5. So then we decrement R5. So 4. So we will multiply 4 and 5. Then it becomes 20, which is 1 4 actually in hex. Okay, so R5 is 4, so it's not reached the 0. We go back to, again, we decrement to 3, then multiply 3 times. Let me do it actually decimal, it's easier to see it. So this was the 5 times 4. Now it will be 20 times 3, which is 60. Okay, we decrement R5 again, 2. 2 times 60 becomes 120. Okay, R5 is decremented to 1. So 1 times 120 is 120. Okay, so we decrement the R5. Now R5 is 0. Okay, R5 is 0. So we jump to the end. But we need to actual value of R5, which was 5. So I restore the 5 from R9. Okay. Okay. Now R6, the X, we will okay, we computed R6. Now we will finish the calculation of X. Okay. Two times I factorial becomes 240, and we add it to the R8. Okay, R8 stores the accumulate. This is the accumulator. Okay, accumulator for X actually. Okay, so this loop is done for only I equals to 5. Okay, and 240 is 2 times 5 factorial. Okay, we go back. I will skip the factorial part, and it gives you 4 factorial, which is 24. Yes, 24. 2 times 24 is 48. 48 is added to the accumulator part to 88. Okay, we decrement R3. Now it's I is 3. 3 factorial is 6. It will give 6, yes. 6 times 2 is 12. 12 added to the 288 becomes 300. Okay, so we decrement R5 again. 2 factorial gives us 2. Yes, and 2 added to the 2 times 2 is 4. 4 added to the R8 is 304. Okay, we go back to R5. Okay, R5 is now 1. 1 factorial is 1 actually. 2 times, okay, 2 times 1 is 2. 2 added to the R8 is 206. Okay, now R5 is 0. Since R5 is 0, our summation ends here. And as we mentioned before, we need to add 2 for the 2 times 0 factorial, because I was, in the end, it was 0, right? So there is one more addition for 0, 2 times 0 factorial. So I added 2 in separate way. So the result becomes 308. And I restore this 308 to R5. Decimal notation. Okay. So that's why for 5, for the video of A equals to 5, we get the result 134 in hex notation, and 308 in the decimal notation. Okay, this is the hex notation. So for the F, we first copy the X to R7. Now R7 is 134 in X position. Then actually we can continue with the decimal. Now 308. So we shift to left twice. So it becomes 4 times X, 1232. Then we add 27, which is 1259. Then we divide it by 2, and it becomes 269. Okay, so this is the F, this is the X, and this is the A, the initial value of A. Okay, So we can also do the